In this video, we are going to divide complex numbers. So in the left red problem here, we can see that we have a complex number 10 minus 3i divided by the complex number 11 plus 4i. Here's where understanding what a complex conjugate means comes in handy. So in our denominator, 11 plus 4i, its complex conjugate would be 11 minus 4i. It's that simple. We need to multiply both the top and the bottom, those are our parentheses, by 11 minus 4i. So you multiply the top and the bottom of the fraction by the same thing. So we're going to FOIL. So up top we're going to have 10 times 11, which is 110. And then 10 times minus 4i, which is minus 40i. Our inside terms are negative 3i times 11, or minus 33i. And then negative 3i times negative 4i, which is plus 12i squared. And then in our denominator, we have a complex number times its conjugate. And out of the FOIL, F, O, I, and L, really the O and the I will cancel, so really we only have F and L. So we're going to do 11 times 11, which is 121. I will write it all out. 11 times minus 4i is minus 44i, and then you can see we're going to have plus 44i. So those terms actually cancel out to 0, and our last is minus 16i squared. So that's the neat thing. That's why we do it. It gets rid of the imaginary number from our denominator. All right, cleaning up the top. This plus 12i squared is really minus 12. So I'm going to have 110 minus 12, and that's going to give us 98. And cleaning up the I terms, we'll have minus 73i. In our denominator, this right here, minus 16i squared, is really a plus 16. So this will actually go down to one term, and it always should. 121 plus 16 is 137. Now I'm okay with you writing it like this. Your book will have it written out as the real term first, and then the imaginary term. These are equivalent expressions or ways to write our final answer. Okay, this next problem is just written really fancy, and negative 1 power really means it's in the denominator. So this is really 1 over our complex number 4 minus rad 3i. So we're going to deal with this in the same way. We're going to multiply the top and the bottom by the complex conjugate of the denominator, which would be 4 plus rad 3i. Again, the complex conjugate, you're just changing the sign on the inside. If it was plus, it's minus, and vice versa. Okay, the top's super easy because it's a 1. So this problem's easier than the one before, which is great. It just looks harder from the beginning. 1 times this is just 4 plus rad 3i. And remember, we talked about in the previous problem, any complex number multiplied by its conjugate is really only the first times the first and the last times the last. So in this case, I have minus times a plus, so it's going to be a minus. Square root 3 times square root 3, which is plain old 3. And I times I, which is I squared. So this turns into 4 plus square root 3i over, in our denominator, it's 16 plus 3, so 19. So we can write this as both the real part and the imaginary part for our final answer. So all in all, when you're dividing complex numbers, you need to multiply both the numerator and the denominator by the conjugate of the denominator, and then you simplify from there, doing what we already know how to do, which is multiplying complex numbers. If the multiplying part was confusing to you, I suggest you watch the 2 videos called Multiplying Complex Numbers.